We're in section 3-2 of the differential equation book in series solutions near ordinary points, and we ask ourselves what makes a point ordinary? Well, if we have a differential equation ax y double prime plus bx y prime plus cxy is equal to something. 0 would be nice. And we rearrange that, dividing everything by a of x, and we have y double prime plus p of x y prime plus q of x y is equal to 0. And then we look at this p of x and q of x, and we say, well, both of these guys are analytic near the point that we're solving for. Then we have an ordinary point. Now, what makes something not analytic? Well, if I divide by 0, then that would be something that isn't analytic, and my solution wouldn't work very well. So if I had something where that some solution, so if I had y prime double prime plus 1 over x y prime plus y is equal to 0, and I try to solve that about 0, and that's what I'm doing when I say y of x is equal to summation n equals 0 to infinity a n x to the n. I'm really solving about a point around 0 where x is. And I might be okay plus or minus 10 either side of the x, but I'm probably not plus or minus 1,000 either side of the x probably. But if I'm dividing by 0 and I'm not analytic at that point, then I can't solve it in that way. I'll have to solve it some way differently, which will happen in section 2.3. Right now we're just going to solve it about what they are. But what we would do in that situation is we'd use a different guy. Would say y of x is equal to summation equal 0 to infinity a n, and would shift away from x is equal to 0 to another spot. So when we look at Taylor expansions, we look at Taylor expansions around x is equal to 0, and we say that f of x is f of 0 plus f prime 0 x plus f double prime 0 x squared over 2 plus f to the nth derivative evaluated at 0x to the n over n factorial. Or we could do a Taylor expansion about a, this is a equal to 0, a equal to 4, and we could say, well, f of x about that would be the same f at 0, f at 4 plus f prime at 4 x minus 4 plus f double prime at 4 x minus 4 squared over 2, and we could call it 2 factorial plus blah 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 plus f to the n at 4 x minus 4 to the n over n factorial. So we could do a Taylor expansion about a different point if in fact we have a singularity involved and we're not at an ordinary point. Normally we like to do it across at a is equal to 0 in the expansion because that makes it easiest for us. Okay, so now we're going to work problems 1 through 18, and with a little bit of luck get done early. Well, we're not going to start at 1 because that's for you to do. So I'm going to start at 2. So I have x squared plus 2 y double prime plus 4x y prime plus 2y is 0. And if I look to see if I have, this is the point x is equal to 0 is a ordinary point, we would put that in the form y double prime plus 4x divided by x squared plus 2 y prime plus 2 over 4x plus 2 y is equal to 0. And we'd say, well, at 0 that's analytic, and at 0 that's analytic. So x is equal to 0 is an ordinary point, so I can continue using the methods that I'm using to solve this particular equation. So I've got x squared plus 2 summation n equals 0 to infinity. Wrong. X equal 2 to infinity, n minus 1, a n x to the n minus 2, plus 4x, summation n equal 1 to infinity, n a n x to the n minus 1, plus 2 summation n equals 0 to infinity, a n x n is equal to 0. So then I would go in and break this up into two parts and say it's summation n equal 2 to infinity, n minus 1, a n x to the n. The plus 2 and the minus 2 go away. Plus summation n equal 2 to infinity, 2n plus 1, a n x to the n minus 2, plus summation n equal 1 to infinity, 4 n a n x to the n, plus summation n 0 to infinity, a n x to the n is equal to 0. Okay, now the only term that isn't x to the n is this term right here. So I do a substitution in him and say n is equal to n plus 2. I would also go back and change this to a minus sign so that I don't get the answer wrong because I muffed up and didn't put a minus sign there. Okay, so now I'm going to rewrite it. Summation n equal 2 to infinity, n minus 1, a n x to the n, plus summation n equals 0 to infinity, 2, n plus 2, n plus 1, a n plus 2, x to the n, plus summation 1 to infinity, 4n a n x to the n, plus summation n equals 0 to infinity, a n x to the n is equal to 0. And then I'd go back and say, well, I'm going to have to start at n equal to 2, so I'm going to have to take n equal to 0 and n equal to 1 out of the second summation. I'm going to have to take n equal to 1 out of the third summation, n equals 0, n equal to 1 out of the fourth summation, so I can put it all under one summation sign. Okay, so I'm going to do that. So I take n equal to 0 out of this guy, and I have 2 times 2 is 4. So I have 4 a2 x to the 0, which I don't have to write down, plus I put in a 1, so I got 2 times 3 is 6 times 2 is 12, a3x. I'm going to take n equal to 1 out of this guy, and I'm going to have plus 4 a1x. I'm going to take n equal to 0 out of him, plus A0, okay, plus 0 plus A1x, okay, plus summation n equal 2 to infinity, n minus 1 plus 4n plus 1 an what do I have left over? I had this guy left over. I had that guy left over. Plus 2 n plus 2 n plus 1 a n plus 2 times x is equal to 0. And with a little bit of luck I did that right. I guess I'll look at it again. N minus 1 an 4n an plus 2 n plus 2 n plus 1 an plus 2. Yeah, I guess I did that right. All right, so I look at that and I say, well, A0, A1 are arbitrary. There are initial conditions that I don't have. I look at the x0 term and I see that 4A2 is equal to A0, implying that A2 is equal to A0 over 4. I look at the x term and I see that 12A3 plus 5A1 has to be 0, implying that A3 has to be minus 5A1 over 12A3. Okay, I got 4A2 plus A0 is equal to 0. That's going to be minus A0 over 4. And then from this equation I have a recurring formula, and the recurring formula, assuming that I can write it down and see it at the same time, is going to be a n plus 2 is going to equal minus n minus 1 plus 4n plus 1 divided by 2 n plus 2 n plus 1. And then we would go and simplify that if we can, and we've got minus n squared minus n plus 4 would be plus 3n plus 1 divided by 2 n plus 2 n plus 1. And that looks like minus 1/2. What happened to my an? an. So it looks like an plus 2 is just minus 1/2 an. Because I can factor this n plus 2, and no, I can't. No, I can't. So forget about that. N squared plus 3n plus 1 which doesn't factor, divided by 2, n plus 1. Okay, so now I'm going to have to, I found A0, I found A1, I found A2, I found A3, so we'll find A4 and A5. Okay, so, and this is for all n greater than, if I could make a greater than sign. Greater than or equal to 2. Okay, so I'm looking at A4, which is going to be minus, n is 2, so that's 4, plus 6 is 11. So I got 11 on top. I've got 2, which is 4, times 2 is 8. 8 times 3. 24 on the bottom. N is 2, A2. Okay, so n is equal to 2. I have 4, I have 6, I have 11. I've got n is 2, I have 4 times 3 is 12, I have 24, minus 11 over 24 times A2, which is minus 5 A1 over 12. What is that doing there? Minus 5 A1 over 12 minus 5 A1 over 12. Oh wow, that's minus 55. Anybody know what 12 times 24 is? 288. A1. Now, I guess I'll have to go to A5. A5, so n is equal to 3. 9 plus 9 minus 19 divided by 3. 5 times 4, which is 20. 20 times 2 is 40. Times A3. A3 is, oh bummer, A2 is minus A0 over 4. Minus A0 over 4. So this would be 11 A0 over 96. 96. Alright, so I've got minus 19 over 40 times A3, which is minus 5/12 A1. Well, isn't that convenient? 5 times 19, 95, 40 times 12, 480, A1, and it's going to be positive. Well, I guess it's time to check our work. So I'm going to say y is equal to A0 plus A1x plus A2, what the heck's A2? A2 minus A0 over 4 minus a0 over 4x squared plus a3 minus 5 over 12 a1x cubed plus 11a0 over 96 x squared, x to the fourth, plus 95 over 480 a1x to the fifth. Okay, so those are the terms we have. Now we're going to go and say y prime 0 a1 minus a0 over 2x minus 5 over 4 a1x squared plus 11a0 over 24x cubed plus 95 over something a1x to the fourth, and 5 goes into 480 96 times. 96 times 5 equals 480. Yeah, okay. Y double prime minus a0 over 2 minus 5 over 2 a1x plus 11 over 8 a0x squared plus 95 over 4 goes into there 24 times 24 a1x cubed. Now we're going to write this guy down twice. Y double prime equals minus 9 over 2 a0 over 2 minus 5 a1x plus 11 over 8 a0x squared plus 95 over 25 a1x cubed. This is the only way we can check it. If there's a better way, I would have done it. I'm supposed to get 0. Okay, so I have x squared of this guy. I have 2 of that guy. I'm going to move back up to make sure. Yes, I did. I had 2 of that guy. Okay, I have 4x of that guy, and I have 2 of this guy. Okay, so I'm looking at moving my line up a little bit so I can write under it. Okay, so I've got 2a0 minus a0. Okay, so 2a0 minus a0 does not get us there. So that means that already we made a mistake someplace, and now we have to go back and find it because I'm not checking. I've got 2a1, 4a1s, minus 5a1s. So the a1 guy checks. What did I do wrong? Did I not take my derivative right? Yeah. All right, well, back up to the top. The problem is written down correctly. Yes. I have a 2 sitting there. I do. It's positive. And right here, see right there? See this 2 sitting right here? You notice there's not a 2 there. and they're supposed to be. There's not a 2 there, and they're supposed to be. When I take the when I take the n equal to 0 term out, there's going to be a 2 here. There's going to be a 2 there. A0 and A1 are arbitrary. For A plus 2, A0 is 0. This is going to be minus A0 over 2. 12A3 plus 6A1. A3 is going to be minus 6 over 12, which is minus A1 over 2. Recurring formula. This is going to be a 0 over 2, so this is going to be a 48. This is going to be a 1 over 2, so that's going to be a 19 over 40. Okay, take our eraser. Are we erasing everything? Pretty much. So this goes away, that goes away, that goes away, this goes away. Okay, so I've got over 2, 1 over 2, 11 over 48, and 19 over 40. Okay, I take the first derivative. This is just a 0. This is 15, no, it's 3. 3 over 2a1. This is 11 over 12. And this is 19 over 8. Okay, take the next derivative. This is just a 0. That's minus 3. This is 11 over 4. And this is 19 over 2. And the next set has to look identical to them. A 0, I have a 3 here, I have an over 4 there, I have a 19 over 2 here. And now it's time to check our work again. Hopefully that would be the only thing we did wrong. I have 2a0, boom, I have minus 2a0. My x term, I've got 2, I have 6, xa1. I have 6a1 minus 6a1. My x squared term, I have minus 1 minus 5 minus 6 minus 6, that's not right. I got minus 6, and that's 11 over 2. We want that 11 to be a 12. That would be better. Okay, right here. A4 is minus 11 over 24 times A2. A2 is minus A0 over 2. Minus A0 over 2. So how do we get rid of this 11? N is 2. 4, 6 for 10, 1 for an 11. Okay, so that is an 11. And that is a 48. Okay, 4 goes into 48 12 times. 3 goes into 12 4 times. Why isn't the x squared term going away? Minus 1, minus 4, minus 6. The x squared term is not going away. Bummer. Okay. We come back up again. Maybe we did that right. We brought the x squared term in. We brought the 2 term in. We brought the 4x term in. We brought the 2 in. X is equal to 0. 2a0. X n is equal to 1. 2a1x. Where's my red thing? See that 2? See that 2? See this 2? Okay, now I've got that 2. This becomes a 2. This becomes an n squared minus n, giving me that, plus 2. Oh, doesn't that just piss you off? Boy, that just pisses me right off. All right, get out the big eraser now. Because now this factor is n plus 2, n plus 1, right? Yes, it does. Just like I wanted it to do the first time. Now it is the job of the first row to correct mistakes like that before they go too far. So n plus 2 is going to be equal to 1 over an divided by 2. Okay, so A3, we already know what A3 is, right? A4, because this is for all n greater than or equal to 2. So A4 is going to be minus A2, which is minus A0 over 2 divided by 2, which is going to be A0 over 4. And A5 is going to be minus A3, which is minus A0 over 2 divided by 5, which is going to be A0 over 10. And that's really a 1, and this is really a 1. All right, so now I've got I've got that y of x equals a0 plus a1x minus a0 over 2 x squared minus a0 over 2 x cubed plus a0 over 4 x to the fourth plus a1 a0 a1 a0 a1 a0 a1 x to the fifth over 10 y prime a1 minus a0x minus 3a1 over 2x squared plus a0x cubed plus a1x to the fourth over 2 y double prime minus a0 minus 3a1x plus 3a0x squared plus 2a1x cubed. I'm going to write that down twice. I want x squared of him, 2 of him, 4x of that one, and 2 of this one, and when I get done I want to have 0. Am I going to get it this time? Okay, that's what I want. Alright, so I got 2 a0s, I got minus 2 a0s. Boom, boom. I got 2 6 a1x's. I got minus 6 a1x's. Boom, boom, boom. I got a 0 x squared. I got 2. I got 2 of them. I have 6 of them. No, I've got 1 of them. I got 1 a0x squared minus 1 minus 5 minus 6 plus 6. So the x squared term goes away. My x cubed term, I've got minus 1 minus 1 minus 7 minus 7 plus 4 plus 4 minus 4. Bummer, bummer, bummer. I got minus 1 minus 7 plus 4 for minus 3. Why is this not a plus sign? If this were a plus sign, my life would be worth living. But it's not a plus sign. And I don't see any reason that it's going to be a plus sign. Okay, this guy's negative, that guy's negative. Take the derivative of it, and I'm still negative. I take the derivative of it again, I'm still negative. I only have 4 of them. That's minus 6, minus 7, minus 10. So this guy would have to give me 10. How can he give me 10? 5 goes out in front, I have a 2. 4 goes out in front, I have a 3 and a 2 there. I don't see how he can give me 10. This is where attempting to do the problem on something other than multiple whiteboards is a problem, because you can't see the whole problem. So where is the problem? Minus 2, minus 2, minus 2. Okay. Minus over 2. This is over 2. That's a 4. Okay, that's fine. Why did I put a 5 there? Yeah, that's a good question. Why is there a 5 there? I bet you that's only supposed to be a 2, and that's supposed to be a 4. Recurring formula is minus an over 2. So minus an over 2 makes it a 4. All right, so this is not over 10. That's over 4. That makes this a 5 over 4. This makes this a 5 and that a 5. Very good. I like it already. Okay, so I got minus 1, minus 6 for a minus 7, minus 10, plus 10. That term goes away. And at that point, I can't check it anymore because I don't have enough terms. Yay! We can now move on to problem number 4. Number 4. So what's the key? The key is not to make a mistake early or at all. Is that possible? Yeah, it's possible. I've done it before. Okay, so I've got x squared n equal 2 to infinity n minus 1 an x to the n minus 2 plus summation 2 to infinity n minus 1 an x to the n minus 2. There's a 1 sitting there. I'll put it in. Plus 6x summation n equal 1 to infinity n an x to the n minus 1 plus 4 summation 0 to infinity an x to the n is equal to 0. I'm going to bring the stuff inside. Summation 2 to infinity n minus 1 an x to the n plus summation 2 to infinity n plus 1. Ooh, no, not n plus 1. N minus 1 an x to the n minus 2 plus summation 1 to infinity 6 n x to the n summation 0 to infinity 4 an x to the n is equal to 0. Okay, well, I want to get everything x to the n, so I'm going to do a substitution in this one. N equals n plus 2. Okay, now that I've done that, summation 2 to infinity n minus 1, an, x to the n, summation n equals 0 to infinity, n plus 2, n plus 1, an plus 2, x to the n, plus summation n equal 1 to infinity, 6n an x to the n, summation n equals 0 to infinity, 4an x to the n is equal to 0. Okay, now I'm going to want to start at n is equal to 2, so I want to take the n equal to 0 guy out of here, the n equal 1 guy out of there, the n equal to 1 guy out of here, the n equal to 0, and the n equal to 1 guy out of that guy. Okay, so that's what we're going to do. N is equal to 0, so that's 2, a2, x to the 0, n is equal to 1, plus 3 times 2 is 6, a3x. I'm going to take the n equal 1 guy out of there, plus 6a1x, the 0 guy out of here, plus 4a0, plus 4a1x, plus summation n equal 2 to infinity. Okay, I've got an n minus 1, a 6n, and I got a 4, all times an, plus I've got an n plus 2, n plus 1, a n plus 2, all x to the n, and the whole thing is equal to 0. Okay, it's a second order differential equation, so a0 and a1 are arbitrary, unless I know what they are, which I don't, so they're arbitrary. Now I look at the unit term here, and I see that 2a2 plus 4a0 has to be 0, which means a2 is equal to minus 2a0. Okay, I look at the x term, and I see that 6a3 plus 10a1 has to be 0. So a3 has to be minus 5/3 a1. Okay, I look at my recurring formula, and I have a n plus 2. Everything inside this bracket here has to be 0. Minus. Okay, I've got an n squared. I've got a plus 5n plus 4 divided by n plus 2, n plus 1, an. Alright, I see my recurring formula an plus 2, and that's minus. I see that this is n plus 4 times n plus 1 divided by n plus 2, n plus 1, an, and those two guys go away. So my recurring formula an plus 2 minus n plus 2 over n plus 4, n plus 2, an for all n greater than or equal to 2. Okay, so now I got to try to find a4. So a4, n is 2, So I'm going to have minus 6 over 4 times A2 minus 2A0. Okay, half, so that'd be minus, that'd be 3A0, 3A0. I look at A5, N is a 3, minus 7 over 5, A3 is minus 5 over 3, minus 5 over 3, A1. 5's go away, 7 over 3, A1. Okay, get another one, A6. N is equal to 4, minus 8 over 6, A4, which is going to be 3A0, minus what? Minus 4, A0? Really? Minus 4, A0? We'll go to A7. A7 is equal to minus 9 over 7 times minus 7 over 3, which is going to be minus 3A1. Going to be positive 3A1. Positive 3A1. This is minus. That's positive. 2 and 3 are negative. 4 and 5 are positive. 4 and 5 are positive. This is positive. That guy's negative. Minus 3A1. Well, yeah, so y is going to be A0 plus A1x minus 2 A0x squared minus 5 over 3 A1x cubed plus 3 A0x to the 4th plus 7 over 3 A1x to the 5th. Well, I don't know how many more we want to do. Plus, minus 4A0x to the 6th minus 3A1x to the 7th. Okay, so y prime, A1 minus 4A0 minus 5A1x plus this is x. This is x squared. Plus 12 A0x cubed plus 35 over 3 A1x to the 4th minus 24 A0x to the 5th minus 21 A1x to the 6th. Y double prime minus 4A0 minus 10 A1x plus 36 A0x squared plus 4 times that, 140 over 3 A1x cubed, 5 times 24 minus 120 a0x to the fourth minus 126 a1x to the fifth. I think we need two of those, don't we? So y double prime again, minus 4a0, 10a1x, 36a0x squared. Now, what would be extremely useful is for the front row to look in the back of the book and tell me that I have it right, so I don't have to do this. That might be a useful thing to do. 126 a1x to the fifth. Or to tell me that I'm so hosed and pathetic that there's no way. Okay, so I want one of these. I want x squared of those. I want one of those. I want 6x of that one. And I want 4 of that one. So I've got 4 minus 4. Isn't that convenient? Okay, I've got 4 a1s. I have 10 a1s. I have minus 10 a1s. That is convenient. I have minus 8 x squared. I have minus 24 more. What's 24 and 8? 30 minus 4. I got minus 8, minus 24 for 30, minus 32. I have minus 36. I got plus 36. They go away. I've got minus 20 thirds. I have minus 30. I have minus 10, and I have plus 140 thirds. Is that 0? That's a good question. So I've got minus 20 thirds, minus 20 thirds, minus 30. I have plus 140 thirds, and I've got minus 10 for 0. So that term is 0. Boom, 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 boom. Look at the x4 term. I've got 12. I've got plus 6 times 12. I've got minus 120. And I've got plus 36 for 0. So that term, boom, 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 goes away. I only have one more term I can check. 7 times 4 thirds plus 6 times 35 thirds minus 126 plus 140 thirds. That did not come up with 0. So maybe I did it in my calculator wrong. We're looking at the x to the 5th term. And so I'll try it again. I've got 21 thirds plus 6 times 35 thirds.
Shouldn't that be 28 thirds?
Where?
The first one. Instead, you said 21.
Oh, I'm sorry. 28 thirds plus 6 times 35 thirds minus 126 plus 140 thirds. 0. Okay, I put it in my calculator wrong. So that term goes away. So 0 is equal to 0, and we have a checking solution. Isn't that lovely? Yes, it's only 4 o'clock. All right. Okay, guys, 6 or 8 next? We'll do 8. See, I told you that if we didn't goof off, we'd get it right. 2 minus x squared summation 2 to infinity n minus 1 an x to the n minus 2 plus 8x summation 1 to infinity n x n minus 1 plus 12 summation 0 to infinity an x to the n is 0. All right, so I've got summation 2 to infinity 2 n minus 1 an x to the n minus 2 minus summation n equal to infinity n minus 1 an x to the n plus summation 1 to infinity 8 n x to the n plus summation 0 to infinity 12 an x to the n is 0. Okay, so I want to do a substitution in this one, n equal n plus 2. And then if I can, at the same time, I want to take the n plus 0 and the n plus 1 term out of that guy, and the n equal to 1 term out of this guy, the n equals 0 and n equal 1 term out of that guy, and boy is that a mistake to try to do.
Make a difference that we're doing like 8 and 9 combined.
Yes, that would make a difference. Am I doing 8 and 9 combined? Shit. Andrew, you're in the front row.
I knew it the whole time, I still want to tell you.
Because there's no guarantee that 8 and 9 combined has an answer. All right, so I got that part right. So I want this to be a minus x, and I want this to be a plus 16. All right, so is that better? I hope so. All right, so that I got that. All right, so this is going to be a minus guy sitting right there, and this is going to be a 16 sitting right here. Okay. Now, what we're going to do, we're going to do this substitution, and we're going to take out the n is equal to 0 and the n is equal to 1 term at the same time. That ain't going to work. That just won't work. So I'm going to go summation n equal to 0 to infinity 2 n plus 2 n plus 1 a n plus 2 x to the n. All right, so I've done that as a preliminary step. Now I'm going to go and remove the n equal to 0 term. 2, that'd be 4. 4a to x to the 0. I'm removing the n equal 1 term. 3 times 2 is 6, times 2 is 12, a3x. I'm removing the x is equal to 1 term, a1x. I'm removing the x equal to 0 term, 16, a0. I'm removing the n is equal to 1 term, 16, a1x, plus summation n equal 2 to infinity. Two n plus 2, n plus 1, a n plus 2, plus parentheses. Okay, now we're looking for the n plus 1 term. So I got minus n minus 1. I've got minus n. I got plus 16, a n, x to the n equals 0. Okay, that's what I have. Okay, now I look up here and I say, well, if I look at the x0 term, I have 4a2. Well, we're going to say a0 and a1 are arbitrary. I'm going to say that first. All right, so I'm looking at the a0 term. I have 4a2 plus 16. a0 is 0, implying that a2 minus 4a0. I look at the x term and I see that I have a 12a3 plus an a1 plus 16a1, and that a3 is going to be minus 17a1 divided by 12. There is no way that's right. What did I do wrong? Oh, I don't believe it. Okay, I'm taking out the a1 term. When I take out the a1 term out of here, there's a minus sign sitting there, right? See that minus sign that's not sitting there? Right here. There should be a minus sign. There's no minus signs over there. I'm not taking anything out of that guy. Alright, so this is a minus guy there. And so that makes it a 15 over 12, which is a 5 over 3, which is slightly better. 5 over 3. Okay, now we're going to look at our recurring formula. A n plus 2 equals. Okay, this term is going to go on the other side of the equation. So we're going to have minus a minus n squared plus n minus n plus 16 a n divided by 2 n plus 2 n plus 1. Okay, so that's going to be n squared minus 16. Okay, so on the side we'd say n squared minus 16, factors n plus 4, n minus 4, right, n minus 4. But that's nothing that I have down here, so I'm totally hosed. And I have to keep it the way it is. Okay. So a n plus 2 is equal to n squared minus 16 divided by 2 n plus 2 n plus 1 a n. Okay, if you say so. Okay, so I have a3, and this is for all n greater than or equal to 2. All right, so I got a4 is equal to, n is now 2. 2 squared is 4. So I've got minus 12 over 2 times 4, 8 times 3, 24 times a2, and a2 is minus 4a0. 1/2, the negative sign goes away, 2a0. I look at a5, so n is a 3, I got a 9 minus 16 minus 7 divided by 2 times 5, which is 10, times 4, which is 40, times a3, which is minus 5 over 3 a1, and this becomes a 7 over 8, 7 over 24, 7 over 24 a1. Okay, rather than to chance our luck, we'll go a0 a1x minus 4a0 x squared minus 5 over 3 x a1x cubed plus 2a0x4 plus 7 over 24 a1x to the 5th. Y prime a1 minus 8 a0x minus 5 a1x cubed squared plus 8 a0x to the 3rd plus 35 over 24 a1x to the 4th. Y double prime minus 8 a0 minus 10 a1x plus 24 a0x squared plus 35 over 8, 6 over 6 a1x cubed. And I'm going to need 2 of those guys, so I'm going to get the other one. Minus 8a0, 10a1x, 24a0x to the squared, 35 over 6 a1x cubed. Now when you do this for the exam, I'm going to tell you exactly how many of the a's I want, so it won't be any mystery. All right, now we're doing number 8, so I want 2, I want minus x squared, I want 8x, no I don't, my finger moved again, I want minus x, and I want 16, okay, So we're going to look at the first guy, the A0 term. I have 16 and I have minus 16. They go away. I look at the X term. I've got 16. I've got 20 minus 20. And I've got minus 1 more. And I don't check. I got minus 16. I got plus 16. Plus 16 minus 21. Okay, so I'm not checking. Big deal. That's happened before. Do we have the problem right? 2x squared minus x plus 16. Problem's right. I brought the 2 in. I brought the minus x squared in. I brought the minus x in. Brought the 16 in. I brought n is equal to n plus 2. I brought it in. Okay. I took out the n0 term. 2 is 4. And 1 term, 3 times 4 is 12. Okay, I brought out the n1 term minus anx. Okay, I brought out the 0th term and the x. I got that guy. Okay, and then I brought these guys together, all those guys in, plus I have a minus sign there. I got a minus sign here. I got a plus sign there. Arbitrary. X0 term 4a2 16a0 minus 4. Okay, that looks right. 12a3 a1 16a1. That's 15. Doesn't that just torque you off? Andy, wake up. What's 15 twelfths? Is that better? Yeah, that's better. Okay, so it's 5. Okay, let's see if we have another problem. Minus these guys. Okay, so that's a minus n squared plus n minus n plus 16. We turn it around. Okay, so that looks good. So everything looks good except A3. So the first time I use A3 is there. So this is a 4. And if that's a 4, it doesn't matter. Oh yeah, it matters. Okay, if that's a 4, 5 goes into there, and this is a 32, right? Okay, so that makes this a 32, but that makes this a 4. Okay, so when I take the first derivative, that is that. This gives me that, but this gives me 15 over 4. And then that gives me, this still gives me a 32. And then this gives me a 15 over 2, a 15 over 2. And this gives me a over 8. Over 8. All right, now, as I was saying, the first guy goes away. Does my x term go away? Okay, so I've got 16. I got 15. And I've got minus 15. The x term goes away. How lovely. I've got minus 40, 50, 64. Minus 64 minus some huge number. There's my calculator. Okay, so I've got 16 times minus 4 plus 8 plus another 8 plus 2 times 24, and that's 0. So that, the x squared term, goes away. The x cubed term, I've got 16 times minus 5 over 4 minus plus 15 over 4 plus 15 over 2 plus 15 over 2 plus 35 over 4, boom, 0. That term goes away. And life is beautiful in the big city. Because now I've ran out of terms I can't check anymore. Okay, so that guy's okay. Now, how far do you guys get to go anyway? You get to go to 19, so we'll drop back to 18, and no, we won't do 18. We'll do 16. Yeah, that's what we'll do. We'll do 16. Number 16, 1 plus x squared, summation, n to infinity, n minus 1, an x to the n minus 2, plus 2x summation n equal 1 to infinity, n x to the n minus 1, minus 2 summation 0 to infinity, an x to the n is equal to 0. We have initial conditions which say a0 is 0 and a1 is 1. Okay, so we already know what a0 and a1 is. They're given to us. Did I write the problem down right? It would appear I might have. Okay, so I've got summation 2 to infinity n minus 1 an x to the n minus 2 plus summation 2 to infinity n minus 1 an x to the n plus summation n equal 1 to infinity 2 n x to the n minus summation n equals 0 to infinity an x to the n is equal to 0. Okay, the only guy we're going to do a substitution is this guy here. Substitution n equals n plus 2. Okay, so I'm going to have summation n equals 0 to infinity n plus 2 n plus 1 an x to the n summation n equal 2 to infinity n minus 1 an x to the n summation 1 to infinity 2 n x to the n summation 0 to infinity an x to the n equals 0. Okay, I'm going to take the n equals 0 and the 1 term out of him, the n equal one term out of him, the n equals 0 and 1 out of him, and when I get done I'll have one summation sign. Alright, so z equal to 0, 2a0 plus 3 times 2, 6a1x. N is equal to one term plus 2a1x. X is equal to 0 minus a0 minus a0x plus summation 2 to infinity. Couple brackets. And I messed up already. This has to be n plus 2. And that has to be n plus 2. So I've got n squared minus n plus 2n minus 1 an plus n plus 2 n plus 1 an plus 2 x to the n equals 0. Okay. Now recapping, a0 is 0, a1 is 1. Now I look at the unit term, I see that I'm hosed.
Where did the 2 go in the last portion of the black?
Where's 2?
Last portion of the black. So they're supposed to,
That 2?
next one to the right. So that's supposed to
There's
be
a 2 there? That 2?
That here.
That 2. That 2 that should be right here. Is that the one you're complaining about?
That's what I was wondering about.
Yeah, so that 2 that should be there, that 2 that should be there, that 2 that should be here, and should be there, but that's a 1. Is that better? Okay. So A1, A0 is 0. It goes away. A1 is 1. And A1 being 1 doesn't matter because that's an initial condition. So A1 is going to be 1. We have a recurring formula, a n plus 2 minus n squared plus n minus 1 divided by n plus 2 n plus 1 a n. Okay. For all n greater than or equal to 2. Okay, we messed this line up really bad, so we're just going to erase it and do it over. I think we did this line before I put the n plus 2 in there, as I think that's probably what happened. All right, n is equal to 0, so that's 2a2. 2a2, n is equal to 1. 3 times 2, 6a3 plus n is equal to 1, 2a1 minus 2a0 minus 2a1. Okay. That's better. Now, a0 is 0, a1 is 1. The x term has to, oh, I left out the x's. Darn. So, this is an x term, that's an x term, that's an x term. Okay, so a0 is 0, a2 has to be 0. a2 has to be 0. a1 is 1, so a3 has to be 0. Six a3 plus 2a1 minus 2a1 has to be 0. Oh, okay, no problem. How did I mess that up? I messed that up pretty bad. Okay, we're going to come back and look at it again. When I have 0 in here, I have 2 times a2. When I have 1 in there, I have 3 times 2, which is 6, a3x. I have the 1 term, 2a1x. I have the 0 term, 2a0. I have the 1 term, 2a1x. Am I? Oh, it's only one minus sign.
X should be the answer.
Hmm?
X should be the answer.
X is never the answer. Oh yeah, X is the answer. Yeah. So what you're telling me is I already have the answer and I haven't identified it yet? All right, now, back to this. A1 is 1. So I have 6, A3 is 0, implying A3 is 0. So if A3 is 0, and A is 0, and A0 and A2 is 0, and A1 is 1, my recurring formula is always going to give me a 0, so y is equal to x. And I remember that from last time I worked the problem. I was just about going to say that, actually. And I'm going to check my work. So y prime is equal to 1, y double prime is equal to 0, and I want 1 plus x squared of this one, and I want 2x of that one, and I want minus 2 of this one, and 0 is equal to 0. My work checks.
How did you get x then?
Huh?
How did you get x then?
Well, what's our thing? I said y is summation n equals 0 to infinity a n x to the n, right? So that's a0 plus a1x plus a2x squared plus a3x to the fourth plus blah blah blah. If this is 1 and everybody else is 0, then y becomes x.
Okay, how do you know everything after that is 0?
Well, it has to be, because if a2 is 0 and a3 is 0,
Oh, yeah, because you told me.
then this is a recurring formula, so a4 has to be something times a2, which is 0, and a5 has to be something times a3, which is 0, so it's going to be 0 too, so everything's going to be 0, and the right answer is y is equal to x. Thank you, Andy, for telling me that, so that I didn't goof off thinking, not recognizing that I not recognize I had the right answer already and I should quit. Yeah, but yeah, that's what it is. Now, you look at that differential equation, And you say, somebody pulled that out of somewhere, didn't they? Yeah, someone did. Okay, control off